Live from New York, it's Ask a Bunch of Engineers.
Hey everybody, welcome to Ask Engineers. We have a quarter dozen engineers on staff today. As usual, it's me, Lady Ada, the main engineer. On secondary, we've got Amanda the Wozniak, who's stuck here due to weather. And also on tertiary, it's backup. It's Riyadh Wabi, who is first time on Ask Engineer, but also an awesome analog engineer, and so we'll be talking to him about all sorts of cool analog engineering and how much it sucks to tape out. We also have Phil, who doesn't really do analog or digital engineering, but it's cool. He can fake it.
Yeah, and I have a very complicated setup tonight. So
he does all the audio and video engineering.
No, it's just kind of,
which is like political science. It's not really science. It's not really engineering.
It's mostly downloading. It's mostly downloading apps.
It's mostly downloading apps. Okay, we have an exciting show with lots of engineering in it, and some fun and fantastic. And it's also the first one of the year. Yeah, it's our first show of the year. So welcome to 2014. Do we have a graphic for welcome to 2014?
We do.
Okay, great. Nice.
This is a light painting.
Okay.
That
just in case you want to know,
our very own Paint Your Dragon Phil B did, that you can learn about on learn.adafruit.com.
Okay, it's 2014.
Yeah.
Let's do this thing. Okay,
on tonight's show, the code is Mo, and we're doing something a little crazy. 14% off tonight, celebrating 2014, folks. And
2014.
Celebrating our new game that's now in the App Store. It's Mo's Resistance, the best way to learn resistance values for kids, adults, everyone. Mo's Resistance.
It's totally like Angry Birds, but it's like angry capacitors.
Yeah, angry circuits.
Angry circuits.
So we'll have a live demo. Also on the show,
watch out for the blue smoke monster.
We'll talk about the weatll We'll talk about As Seen on the Show and Tell.
Wintry Mix.
Pack of the Mailbag. We'll stop by. Well, he's a letter, and then there's the Mailbag. We'll have a little preview of a video we're working on for Mo's Resistance. We have some fritzing that came out, some Legos, some news in the world of open source hardware. We have a special announcement. We're doing a hardware hangout soon. We have news in the world of Arduino, a tour of the Adafruit learning system, and a bunch of cool stuff that just got published. Wearable Wednesday, all the things that's fit to wear. 3D Thursday, all the things that's fit to print slowly. Pi Day, we show a bunch of Pi projects. There's like 2 million Pis out right now. We're going to have some new products. We're going to answer your questions. We'll have a trivia question. All that and more on Ask an Engineer. All right. Okay.
Okay.
So let's
we're back.
Yeah, let's pay some bills here. Don't forget, the code is Mo, 14% off. We probably won't do 15% off next year. So now is the time. So this sale ends tonight at midnight, and 14% off. And one last reminder, we take Bitcoin. Bitcoin's back up. It's like $800 now.
Oh, really? Spend them now.
Yeah. Trust us on this.
Fast.
Get rid of these Bitcoins.
Get rid of these Bitcoins and buy electronics with them. It's a good idea. You can buy 500 Bitcoin stickers with 1 Bitcoin.
Yeah. So what we're going to do tonight on the show is we're going to blow through the show really fast so we can spend time with
this lovely
Woz, and
pair
one of the only
engineers.
male engineers that I've ever met.
You're
It's
right.
cool.
This is the first
We're pretty rare.
Yeah.
We're a rare breed.
we have a man-engineer.
It's cute. You're like
Caption.
it's a little
tough,
engineering
You know,
job.
it's tough to be in the engineering industry as a guy, but I do what I can.
Yeah.
I know, you're just surrounded by women.
It's
They're
true,
all
all the
judging
time.
you all the time.
Constantly.
Asking
Yeah.
you.
You should learn how to code.
Yeah, bro. Learn to code.
Okay, so real
Okay.
quick, we're just gonna zoom through the show. Ready, Lady Ada?
I'm ready.
Okay. Everybody who ordered a bunch of packages, there might be some delays because
Wintry mix.
Wintry mix is here.
That sounds like a really good thing you want to listen to. Like, oh yeah, I downloaded the wintry mix of Beyonce's new album, but
Yeah.
no, it actually means your package is stuck in Tennessee or
The John
something.
Coltrane
in
channel
some-
on Pandora.
Yeah, but
Wintry
it's
mix.
also in a warehouse, and so I know you wanted your stuff overnighted, but planes didn't get to take off on Friday.
Yeah.
Most planes don't leave New York.
Okay, so we had the show and tell. Show and tell was packed. It was awesome. Lady Ada, quickly just go through what was on the show and tell. Go fast.
Yeah, we had a lot of people. Okay, first up we had Terry, who is just totally awesome and is always showing up with the best things ever. And she created a shadow box for her lasercade, which she showed before, which was really cool, the little asteroids lasercade. And she also showed off a trellis game, so she used our 4x4 button matrices, and she made a cube of them, and then you have this accelerometer-based maze game where you go through the maze one room at a time, and it was pretty cool. Tony came back, and he's been doing face recognition stuff with OpenCV and Raspberry Pi, and this time he made a treasure box, like a pirate booty box, except it had a Raspberry Pi and a camera in it, and it would not open the latch until it recognized your face. So you learned a lot about OpenCV and how it does eigen faces, which sounds like something kind of cool. And then he just showed what these images looks like, and it's kind of interesting. And I guess the Raspberry Pi is good to do facial recognition, so check that out. Maybe people can do some. I suggested he does a cat face recognition because he did a cat feeder project. So now he has to have it so one cat gets fed, but not the other cat. Only if that cat's good, or I don't know. I don't know if he has two cats. Anyways, and then Kevin came by and he made a pair of NeoPixel goggles, which is the fashion accessory for winter 2013-14. I saw it on the runways, and so build them for yourselves. And he 3D printed a nice little diffuser for them so you can actually see through without going blind, which is also cool for 2014, not going blind. Emil came in and he built all sorts of NeoPixel stuff for the holidays. He showed off a nice window frame thing that counted down, what the day was, and then New Year's, I guess it exploded in a bunch of fireworks that were made out of LEDs. And he made a nice little NeoPixel bracelet. And he learned what happens if you short out of a lithium polymer battery. It explodes, so that's why you shouldn't do that. So don't do that. And it's a nice little bracelet. It has a little magnetic clasp. Very cute. Don't get sued by MagSafe and Apple. Okay, Donald and Helen were next. They showed off some cool glass working that Helen makes that absorbs red or green light particularly well. And so they use a NeoPixel where you can actually adjust the amount of red, green, and blue emitted digitally. To actually figure out exactly at what point, the inflection point is for the red and green. Turns out it's 20%. They did science. Good for them. And then finally, Boyan showed up, and he's doing home automation, and he discovered the Dallas one-wire protocol, which is pretty cool. And he's using a USB to one-wire adapter, and so he can use the file system on Linux, which is neat. Also, if you're interested in that sort of stuff, check out our Raspberry Pi one-wire tutorial, which covers the stuff for Raspberry Pi in case you want to do it with Raspberry Pi. But you can do basically temperature sensors, which is kind of like the DS18B20s, which is kind of what, as far as I know, what is really used with one wire. Although there's a cool one-wire thermocouple sensor that just came out we're checking out. So he's using all sorts of online sensor protocol systems to graph his data. It was a full house. It was 1, 2, 3, 4, 5, 6, 7 people with projects. That's a lot of people.
All participants on the show get as seen on the show and tell sticker. Just email support@adafruit.com. Don't forget to watch the show and tell. It's now
Oh wait, I
posted
forgot
up
Lewis.
on YouTube. Okay.
Lewis was doing a project for school. Maybe sorry I skipped it. Lewis did a project for school with Pi home automation, and there was an awesome garage thing, and it was stop motion, and it was totally awesome. He's going to do 2 more projects for school, and he's probably going to get an A.
Okay.
And then he's going to put me out of business.
All right.
right.
I'll do this part. To get on the show and tell, just post a link on our show and tell post on Google+. We're going to keep moving. Next up, pack of the mailbag.
Everyone was covered.
Pack of mailbag. Letters. You guys send letters. We read them on the air here, as they say. This is from Scott. I've only recently started in the world of electronics, but through my experience ordering from Adafruit always seems to be the fastest and easiest with getting my package to me. Thank you,
Not only
Scott.
seems, but is.
Yeah, seems is. Okay, here's a special preview. We launched a new video game. Here's Tom with the puppets.
Not only doing receiving, but also puppeteering.
Yeah, and here's a little preview. We're doing our big promo video. You'll see this around soon. This is Mo's Resistance. This is, we think, the best and fun way to learn resistor values. Here's what the Blue Smoke Monster.
It's totally better than screwing up your filters and wondering why they don't work and then looking it up with like an iPad app or something. Just learn it.
It's in the App Store, and one of the things that we always do is the cost of the game is 99 cents, but there's a 99-cent off coupon, so it's basically free. So please try it out. We wanted to teach kids something fun, more than just the video games that are out there, something that's educational. And even on our captcha, on our blog, we have resistor values that you have to put in to comment.
And we have no spam on our blog.
We have zero
You'll
spam.
notice.
Yeah. As soon as Adafruit gets spam on the blog, it means everyone is doing electronics.
That's good.
All right. Okay.
I feel like if a spammer learns resistor color codes to spam us, I'll let
okay?
it through.
Okay.
Yeah, I'll be like, that's cool.
Okay.
All
right.
Yeah, that's worth it.
We had Fritzing Friday. Every Friday we post up a new Fritzing part. This is the 16 neopixel rings.
Yeah, great for your LED goggles. Yep. Look at these nice little nice work, John Engineer.
Next up, there's a new Lego figure that someone made. It's an Ada Lovelace figure, isn't it?
Yeah.
Yeah.
Nice.
It's also the Princess Leia one, I think. Okay. Next up, milestones at Adafruit. We hit 6 million views on our YouTube channel. That means 6 million views of learning electronics and more. Thank you, everyone. It's youtube.com/Adafruit. Okay. We have a bunch of top 10 posts this year because we did a wrap up. So as we get to certain topics on the show tonight, if there happens to be a top 10 that went with it, I'll do it. And so here's some that are kind of on the edge of that. This is the top 10 Blinky posts for 2013. The Raspberry Pi status LEDs explained. That was our #1 post that had something to do with blinking LEDs.
Okay.
Some of you probably want to know what was the #1 post on Adafruit. Well, oddly enough, it was us talking about Pizza Hut, which was PizzaNet. It was one of the first web pages.
What's cool is this is the top post on every blog every year because nobody remembers Pizza Hut Net.
Yeah, it was the first. PizzaNet was a commercially licensed and bundled internet operating system.
And then we also did the post I think a couple years ago about Corey Archangel did the command line version of this that allowed you to pizza party. You could order pizza from Pizza Hut on the command line with dash pepperoni or dash onion.
So this hit Reddit, so that's why it just went nuts.
Reddit.
Okay, but the second most popular post, which I thought was cool, was your Manufacturing Monday post. This is when we got the pick and place.
Aww.
It's you in front of this dragon machine. It's cool. All right. And then we also had John Engineer picked his favorite photos. This was Colin. This is one of his favorite photos.
That's a classic Colin photo.
Yep, you'll be seeing a lot of Colin this year, everyone. He has worked.
We're letting him out of the cave.
Yeah, he just finished the game. For art, this is one of this is our top post. 25 abandoned monuments from the future. It's kind of nice. From science, NASA's massive ebook collection. That was our #1 post from our science collection. So I have some more. We're going to keep going, though. So some news in the world of open source hardware. Everybody here likes open source hardware. Bunny released a really cool micro SD talk from
we chatted with him about the SD and micro SD. I think this is actually, I don't know if it's SD or micro SD. We talked about him over lunch a couple weeks ago. And he said he was going to the Huaquang Bay, I guess, the name of the shop in Shenzhen. And he kept going to all these sellers, and he was actually trying to get the crappiest SD and micro SD cards because those were the ones that were more likely that he could open them up and actually see the chip because they weren't all fully integrated. So he'd go there and he'd be like, no, I want the knockoff Kingston. And they're like, no, these are not knockoff. He's like, no, I want the knockoff Kingston. So it was kind of cool. He's been researching this for a while, but he's discovered the microcontrollers that are inside the micro SD card. What's interesting, what I thought was interesting was all micro SD card memory is, it's hand assembled and it's recycled. Yeah. It's almost rarely, it's not, from some places it is new, but for a lot of times, especially if you're getting low cost SD or micro SD flash, it's actually recycled. And 80% of the sectors can be bad, but if the microcontroller just skips the bad sectors, that's good enough. So that's what they'll often do is they'll just take an 8 gig piece, put it on there, only 2 gig, 4 gig pass, that's what they mark it on. Like whatever passes is what they mark the SD as. So fun time. Open up your micro SD cards. If they're broken, why not? You can maybe check out this stuff inside.
More news in open source hardware. BeagleBone announcing market share numbers, 100,000. They hit the 100,000 mark, BeagleBone Black, and we get a shout out. Sold directly from distributors such as DigiKey, Mouser, and Adafruit. We sell these really fast, and we have a lot
we're out.
They are awesome.
Yeah. They
even the peanut gallery agrees.
Yeah. Most guy engineers like BeagleBone Black.
Guys like BeagleBone Black, yeah.
Choosy engineers choose BeagleBone Black. Okay. We had our Manufacturing Monday post. I'm just going to go through these fast. This is when I run around the factory and just take photos of whatever we're making.
With a toy filter.
Yeah. Well, look.
These are the 24 LED NeoPixel rings. This is kind of a pain in the ass to manufacture because they're hollow on the inside. So you can see we have to do this weird panel shape, and this is the stencil that goes with it.
And then last week, Lady Ada talked about all of the
These are my stencils.
Cool new things going on with our stenciler. This is one of the posts.
These are ginormous stencils. They're so big. But interestingly enough, they're about the same cost as the stencils I get now. Yeah. The cost of the stencil is actually the cutting, not the actual material frame.
Okay. News in the maker business world, Tindy announced that they're changing the fees, so their fees are now 9%, which is still lower than eBay and Amazon. And this came after 2 months of talking with their community. Tindy is one of our favorite places to point people to when they make hardware, because they're like, well, I don't know, how can I get the word out to, I have a new kit or a new project, and Tindy is one of the best stores to go to. So go to tindy.com and check out all the projects that are there that you can purchase.
Or sometimes people are like, oh, I have this like FPGA driver board, you want to carry it? And we're like, well, we don't think we'll sell a lot through our store, but we suggest you go to Tindy and like go there because you'll make more money.
So OSH Park, Tindy, and like all these, all these like maker companies are really making it easy to be a hardware entrepreneur. And speaking of, this Tuesday, Chris Anderson, former editor-in-chief of Wired, guy who put you on the cover, now he quit that publishing gig, and now he's CEO of
Drones
3D Robotics. So we're going to have him on our hardware hangout. We do this about once a month. And Lamore's going to basically interview Chris.
It's going to be about hardware, about business, about DIY drones and 3D robotics, manufacturing Tijuana. He has 6 pick-and-place lines now. So I'm going to ask him about that. Maybe we'll ask him about test procedures. We'll just ask all sorts of questions.
Yeah, and we have the Iris. We'll have them back in stock soon. So okay.
Yeah. Nice quadcopter.
Next up, we're going to go to the Adafruit Learning System. So we're up to like 380 tutorials.
I know, I got to do 20 more tutorials.
Biggest and best resource online to learn electronics. So here are the tutorials that we put in this week. Let's go. Okay.
This one is, this is the Android with Arduino. So this is actually interesting. This was done by Mike Borella. He said he'd been actually playing around with this stuff. And I'm like, I don't know anything about programming Arduino with Android. He says, well, you kind of can't really sort out. And I said, well, why don't you talk about what you can do and what you can't do? So he actually went through a bunch of different Android tablets and Windows tablets and talked about how and what kind of Arduino programming you can do using either paid apps or installing software. It was kind of interesting because I didn't know anything about this stuff. So if you're interested in doing hacking on the go, check this out. It's possible to do some Android Arduino programming. Unfortunately, I thought that you could port the Arduino operating system app to Android, but apparently you can't really. You have to use this paid app, which sort of emulates an Arduino IDE.
Yeah,
but
it gets complicated really fast.
Check it out.
Okay, moving right along. Next up, this is Raspberry Pi with an Adafruit OLED screen.
We got these OLEDs. They're so cute, and you can use them with the Raspberry Pi really easily. And there's already code for it. So it just shows you how to do the wiring up, display images, text, whatever. It's all good. And there's lots of animated GIFs.
Next up, we got our USB power gauge tutorial.
Yeah, it's just how to use it, how it works.
Self-explanatory.
Yeah, pretty straightforward.
Next up, we've got our Trinket Bluetooth alarm. This is from Mike.
Yes.
This is a great tutorial.
This is how to do your own small home alarm system that has 2 magnets and a PIR sensor, uses a Trinket, and then it uses Bluetooth to send the data back. So if somebody like cuts the wires because they're like hacking your home hacker place or whatever, you'll get a Bluetooth notification, so it's wireless. So it's kind of cool, and it runs off a battery. And I just think it's nice. He took a whole bunch of different parts from the store and put them into a box.
Okay. Next up, we've got technical issues. That's what we got. All right, let's go back to this.
Okay.
All right.
Okay.
This is really cute. I'm just gonna go straight to the video on this one.
I know. So cute.
Yeah. So this is a little 3D printed Trinket bot.
Yeah, it's a little 3D printed robot with just like 2 micro servos and a sonar sensor and a little trinket board. And this is the smallest, simplest, and the body is a 4 AA battery pack. So it's the smallest and simplest little rover you could make, and it uses little plastic bracelets to shreds, which is super cute.
And then this is a new product, so we'll go over this soon. This is the new Adafruit 2.8-inch TFT Touch.
Yep.
Shield version 2, we'll go over that soon.
Twice as good as version 1.
And last, this was one of the top 10s. Top 10 learning guides of 2013.
Okay.
Here it is. You're not gonna expect this one. It was one of the most recent ones. The NeoPixel Painter
is the top
is the
one?
#1, and this is one of the graphics from it.
How many views? Do we know how many views?
I think we posted up on the site,
Okay.
but it was the top one.
Wow.
Yeah, really made the rounds. People really wanted to make animated GIF light paintings.
This
Okay.
is so cool.
All right, next up, Wearable Wednesday.
It's the optical encoder that does it.
We're going to see how much more we can get through these.
Let's
Wearable
get these costumes.
Wednesday, all the news that's fit to wear. We did a wrap-up of the year with some cosplay stuff. Here's some of the new ones. This was the #1 post in the costuming. And then here's the ones from this week. This is a dragon costume that someone made. Cardboard. You can see Home Depot stuff. This one was a really popular one this week. This costume is made out of bottle caps.
Yeah.
Some of these look like they're actually in movies, but these are costumes that people are making at home
This is a death
and
elf.
sharing. Yeah. And then this one is creepy statue cosplay.
Yeah.
So
Creepy
be sure to
statue.
check these out if you want to learn how to make these. We actually show the resources on how to do that. Next up, a coming soon post. This is our new project that we're working on. It's flexible, printable material, and it uses a Gemma and NeoPixel and some other things.
Yeah, it's cool. Extrude rubber plastic.
Another top 10. This is our recap show. Top 10 wearable projects. And #1 was this incredible knit skeleton dress.
And that's a nice skeleton dress.
And for our wearable videos, this was the top 10 wearables of 2010. This was the glowing Chuck Taylor shoes. That was me skateboarding.
Starring you.
Yeah, glad I didn't fall. And then last up, one of the things that we posted up on the site, this is the Firewalker shoe project on a cast.
Yeah.
Yeah.
If you're going to have a cast, you might as well attach some electronics to it.
Yeah.
You got a lot of good material there.
Yeah. And
You can put a big battery on there.
next up, we have an EL wire video
Okay.
that I'm going to show the very beginning because we're going to get to our guest soon.
Yeah.
We still have a lot of show to do. So I'm going to show the beginning of it, and you guys can watch the rest of it later.
Hey everybody, it's Becky Stern here at Adafruit, where today we're talking about electroluminescent materials. EL wire, for short, is a stiff wire coated in an electrically sensitive phosphor. It lights up like neon, it comes in a bunch of different colors, and it's one of our favorite ways to make projects glow. So here's how EL wire works. Smaller wires wrap around the phosphor inside the PVC sheathing, called corona wires, and alternating current applied across the inner and outer wires makes the phosphor glow. EL tape and panel work in a similar way, where 2 layers of a dielectric material sandwich a layer of phosphor. EL materials are great for adorning wearable projects, like a fun animal mask or a hooded sweatshirt. Since EL tape and panel conducts evenly over the whole plane, you can cut it or mask it with vinyl to make any shape you want, as long as the cut shape is contiguous with the power connector. All EL materials need to be powered by an inverter. An inverter translates the DC voltage coming from the batteries into high voltage alternating current, or AC, required to excite the phosphor. Although it's high voltage, EL uses very little current, so it's safe to wear. We carry a few different flavors of inverters here at Adafruit. These battery-powered pocket inverters are great for increasingly large amounts of EL, from the tiny star on this shoe to something a bit more involved. For something bigger like a couch, these inverters can easily be attached to a 12-volt AC adapter. This one is even sound reactive. To solder to EL wire, first carefully strip off the outer PVC sheathing. If you accidentally...
Okay, so that's the cliffhanger ending. So
How do you solder it? Well,
So,
watch the video to find out.
yeah, watch the video. It's a great video. It's about 3 minutes long. It tells you all about EL and more. Next up, 3D Thursday. all the news that's fit to print. Now, we did a giant wrap-up with 3D printing stuff.
It was huge.
There's interviews with all the stars of 3D printing, all sorts of stuff going on. I just have one thing. I thought this year was fantastic because the RoboHand project made the rounds. We did the all the chats.
Yeah.
For 1 month, we did, it was called Make the World. And it was just really neat to see people make prosthetics and get them out there and actually start talking about using 3D printers for things, you know, that are helpful, that are useful. Very futuristic, very interesting. Great to see a wide variety of people around the world participate in that. So that was my favorite part of the year.
Okay.
There is some big news, and we're not going to spend any time on this because if we didn't have guests, this would be probably the topic of the evening. Affinia is going to countersue and fight back. So Stratasys, which owns MakerBot, sent a note to a note, yeah. they're basically saying like you're infringing our patents, and people didn't know what Affinia was going to do. They're basically saying no, we're not, and we think you're trying to act like monopoly, and we want a jury to decide. So they're in the world of what this is, what this means. It means they're not fighting, they're not looking to settle. They're saying this is wrong. So 3D printing is going to be really interesting this year. I think it's tough as a business to find a 3D printing company that's not either sued or suing or being sued or in one phase of those things. So for us, we still don't know what we want to do. It's complicated. We're going to continue to watch this case, and it's a big one because the patents that Affinia is saying that aren't valid do affect everybody in 3D printing. So it's going to take a long time and a lot of money.
Yeah.
Big news though. Fighting a patent lawsuit is a huge deal. Okay, next up, Pi Day. I'm just going to do one. This is our #1 Pi post of the year. It's when someone made this Raspberry Pi miner for Bitcoin. So this is what they did. They just
Don't worry, they lost money. Yeah, it looks like they.
I think this is one of the folks who bought a bunch of stuff on our site.
I don't know, like 20 cards of like 20 chips. Those chips are expensive, unless you fab them yourself.
Yeah.
They're pretty expensive.
Okay. Here we are.
But we're interested to see, like, did they actually make their investment back? I mean, maybe at $800 a Bitcoin.
Yeah, I think it's up to like 900 again. Okay, before we start new products, just a reminder, the code is Mo. 14% off. This is crazy. 14% off. Everything in stock, except for you can't use the code for EagleCAD because it's software.
Okay.
We sell EagleCAD, by the way, right now. Yeah, it's not bad, right? Okay, and that's in celebration of Mo's Resistance, available in the App Store now. You can search for Adafruit on iTunes and get it. Okay, Lady Ada, it is time for new products.
Okay.
You want to do this?
Yeah, I'm right here.
Okay, the first product is not a product.
Wait, what?
What was the top new product post of 2013? Trinket.
Really?
Trinket became our #1 product post.
Okay.
That everyone shared. Posted
It was one of the, we
Yeah.
sold more trinkets than almost anything else, I think, that year too. We should do. I mean, we
Yeah.
were selling like 9-volt adapters and stuff.
Okay, go Lady Ada.
Okay, first up is this USB switch. So this is a USB switch. We have these switches for DC power, and I thought, well, you know, like you might want to have one for like USB battery packs or something or other. Like basically, if you don't want to have to unplug USB. So it's basically USB female on one side and USB male on the other, and there's no data connection. It's just power. So turn on, turn off, and you've got yourself like a USB power switch.
Okay, great. Moving right along to the next thing. We've got these. What are these, Lady Ada?
These are pure green LED matrices, and I have a demo here with both kinds. So we have them both individual and small and large, and with the backpacks and without.
Okay. I'm just going to go through all these.
Yeah, can you
beautiful
go to
photos
the overhead, actually?
Yeah.
That'd be most useful. Okay. So, ooh. Let me see. Hold on. Let me get this. Okay.
That's nice.
So you can see that this one, it's actually tough to see because cameras don't pick up the yellow in these displays as much. But you can see this one's actually kind of more of a yellowish green. And this one is much brighter, and it's like a bluish green. It's a much more intense green color. They're two different processes. This is a higher forward voltage. It's a teeny bit more expensive, although when we can, we try to make it the same price. But you know, if you've ever had like yellow green LEDs or pure green LEDs, you know that I think the pure green looks a little bit better. But some people might think the yellowish green looks a little bit better. The yellowish green is a little bit more of a grass green, and the blue is a little bit more of like a jade green. So, you know, 2 different LED colors. So this is the 2 larger ones, and then I'll also show the teeny one, and then you can see that there are these backpacks. So hold on, let me get this going. 1 second. Okay. So this is the teeny matrix, which is like super, super cute. You can see it's also running the same code, but it's just a lot smaller. So yeah, we basically have these now in pure green because the place we get LEDs from is like, hey, we can get you pure green for a pretty good price. And I was like, let's do it.
Okay.
So now I think we have all colors of these LED matrices that are available.
And last but not least, we have, this is kind of a big deal, right, Lydia?
Yeah, I finally finished this version 2 of the Shield.
Okay.
So this is a touchscreen Shield.
Look.
Go back twice.
You go back.
This
Which one?
There you go.
Sure.
This is a touchscreen Shield that plugs into an Arduino. And we had version 1, and we actually discontinued it a couple weeks ago. And this is version 2. And this is a view from the bottom, so you can see that there is a micro SD socket on the left. And the LCD connects sort of in the middle there. And then we have surface mount connectors so that it's already assembled. You just plug it into an Arduino and it runs. And one of the nice things that we did is we put in a surface mount connector on the right, so you can see like it can plug into a Mega or a Leonardo without having to do any firmware changes or anything. So it uses a hardware ICSP connector for like do a Leonardo Mega Arduinos and also future Arduinos as well. So as we've been redesigning all the Shields, we've been fixing that. You know, with a lot of older Shields, they were for like Uno only, and then all these other Arduinos came out. And I'll just show it really fast on the overhead. This is just the touchscreen demo. So, you know, you can do a little painting. We also have code for, you can load images. We also have a demo that has like all sorts of text and graphics. So it uses our GFX library. You can see here how it plugs in.
Is the resistive touch overlay on the V2 the same sensitivity as version 1?
Yeah, but this, another thing that this Shield version has is we put a touchscreen controller on it. And the nice thing about the touchscreen controller is it's a 12-bit ADC that runs in the background, and you talk to it over SPI. So you only need 1 extra pin to talk to it. And so you don't have to constantly be polling the resistive touchscreen. There's an IRQ if you want. So it can like do all the touchscreen reading, and then it pulls the IRQ, and you can say, oh, now there's touchscreen data in the last few seconds, and read the touchscreen data. So even though it's the same basic display, the touchscreen I think is a little easier to handle now because it's managed by a totally separate chip.
Okay. Next up, I'm going to do the next one. You know why?
I don't know.
Because it's fun.
Okay.
All right. So this is a big wire mess. This is what you turned from the wire mess into. This is our new display port adapter.
Yeah, that's what it looks like when you have 12 channels of constant current LEDs, and you have your LEDs on one side of the table and your constant current driver on the other side.
And so here's the photos. We're about to release this, and so it's a sign-up page. It's a little tiny, high-resolution iPad Retina display screen that you can use with a DisplayPort computer. This is how it shows up on a Mac.
This is Apple Color model.
Yeah, it shows up at 2048 by 1536.
Yeah.
And
it's funny, it's about the same resolution as your like 18-inch monitor or 19-inch
yeah.
monitor, but it's like super teeny.
Yeah, and so
if you like drag a window, it like shrinks.
Yeah, so this is pretty much going to be the ultimate accessory for the new Mac Pros because it's a little tiny Retina display that just plugs into DisplayPort.
The Mac Pros are like this big, right?
Yeah,
They're like
so
super teeny.
I have a very short video. It's like less than 30
look
seconds.
like the monolith, but they're actually quite small.
Okay, here is the new little Retina display. Okay, so sign up now because it's going to go extremely fast. We have a quick demo that we can show. So it's plugged into my secondary computer over here right now. So I'm going to reach over.
Whoa.
And
Okay.
grab it. Yeah, it's crazy, right? This is why the show was complicated tonight amongst other. So here's the back of it, and then here's the front of it, and you
Yeah,
can
this is
see.
beta.
Yeah, and you can see it's a beautiful screen. And let me just drag over the chat window.
Hey, what?
Yeah,
Whoa.
so here the chat window is now can look at itself.
Creepy.
Yeah, so that's weird. All right, so
So you can use this instead of like you have like this monitor over there. So
yeah,
just
well,
use...
I use it every day on my computer because I need a secondary screen for like video editing or like whatever.
Yeah.
So it's kind of nice. All right,
Okay.
so that's our screen. Okay, and with that, we are done with new products, Lady Ada.
Yeah, so that's a sign up page because I'm ordering components and it's I have to buy a lot of them. If you would like one, sign up and you know, we'll add it to the order. You don't have to pay for it. It's just so I have an idea of how many I'm buying.
Yeah.
Okay, great.
Yeah, right now there's already a few hundred people signed up, so do sign up fast.
Yeah, because whatever I order for the PCB one, it takes a couple weeks.
Okay. Everything you saw that was in stock that we just showed, 14% off.
Okay, great.
Get it now. Okay, now if we can have Waz and Riyadh get over here. And I'm going to change my mic so that you should start talking because I'm on mute.
All right.
I might.
Do you guys have mics?
He
Do you
does
have a
not.
mic? Do we
Yeah.
do we have the portable
I know
mic?
sign
Okay.
language, though.
Here.
Okay.
Mic up and then unmute it.
All right, great. I will move over. Okay, great. So now we have Waz. Everyone knows Waz. Waz has been around here, and then Riyadh can come in here.
Hey Waz, can you
Okay.
say something?
Oh, yeah.
Okay, great.
Testing, testing. Okay, great. And we also have Riyadh.
Hey, how's it going?
Riyadh, this is Riyadh's first time on Ask a Juror, which is, like we said, this is also one of our
Nervous.
first engineers.
Yes.
So you recently were at Scilabs.
Yes, I was at
that's,
Silicon Labs.
That's in Texas.
Yeah, we're based in Austin, and
But you hate Texas Instruments.
hate is
There
a
has to be a
strong word.
rivalry, right?
Well,
it's like Army, Navy,
TI is so much bigger than us
Yeah.
that like it's not a matter of hate. Like we definitely compete with them on certain product lines, but
How big is Scilabs? Like how many people were working there?
800, 900, I think.
Okay. Are you guys fabless? You don't
1,000.
do their own fabrication. You outsource.
Yeah,
that.
we're fabulous.
Okay. And what
Fabulous.
kind? Fabulous. Fabulous and fabulous. And what kind of chips is Silicon Labs known for?
So they have.
Other than the CP2102.
Yeah, right. All the microcontrollers. So there's the two microcontroller product lines. One of them is the 8051 based one, and then the more recent ones are ARM based. And they've got there's the 8-bit microcontrollers, 32-bit microcontrollers. Then there's a lot of more industrial stuff. They have a lot of TV tuners, so the terrestrial and cable TV tuner and demods for like DVB-T and stuff like that. So that's like built into a lot of LCD TVs and stuff like that. They have some much older stuff that's been like for a long time, sort of the baseline that provides all the sort of money for R&D. So like one of the first products that they had was for landline telephony. It's called a DAA, a direct access arrangement. So there are all these laws about like when you have a telephone line, if you want to connect to the telephone line, then you have to be able to withstand like lightning strikes and power cross events and stuff like that. So it used to be that you would have transformers that would do all that. So like if you look at really old modems, they have transformers like on the board.
Yeah, there's a big chunky.
Yeah.
Okay.
So in order to get the same performance, they built this chipset. This was like the very first product.
There's no
like
transformer inside it. No.
it's actually capacitive rather than transformer based. I think other companies have done transformer based ones, but basically you have these external like 5 kV caps. And then there's like the line side one, which is like the high V part, and it has like an A to D converter in there, and then and then it communicates back across the capacitive link to the system side one, and that one provides like a digital interface to.
Was Silicon Labs spun out of another company, or was it started by somebody?
So the three guys that started it were at Crystal Semiconductor, which is now Cirrus Logic.
Crystal, yeah.
Yeah, right. Back in the day,
like the old,
Crystal,
like
the old
Ethernet, like all that
Ethernet and
stuff.
like video cards and stuff like that.
Yeah.
That was Crystal.
Crystal, okay.
But so the three guys that started it left from Crystal. They started Scilabs, and then I think Cirrus Logic bought Crystal, and like they kept the Austin Cirrus / Crystal Center kind of. That one's actually experiencing a pretty big renaissance now because they're used in tons of Apple products. Like all the audio stuff in Apple products is Crystal. Or is rather Cirrus Logic. But there's like a lot of interchange between the Cirrus Logic people and the Silicon Labs people. It's kind of cool. Like we're not really rivals because we don't really compete in anything. So like everyone's friendly and everyone knows everyone because I mean half the people there worked at Cirrus previously.
Yeah.
So it's kind of a cool, like Austin has a very small very small semiconductor scene, and so everyone knows everyone else. Well, yeah, and honestly, like, yeah, pretty cool.
One question from the audience, they wanted to know what is the business model for a fabless provider? Like, how do they make money?
So it
Clients.
depends. Well, it depends on the company. So the problem with owning a fab is that if your fab is not constantly at max capacity, then you're losing money. Like, the fab costs you a lot of money up front, and then it also costs you a lot of money to maintain it. So if you can't keep it at full capacity, then you're just like flushing dollars down the toilet. So the idea is you have somebody like TSMC or one of these like very big semiconductor companies, and they invest in building new infrastructure, like building new production lines and stuff like this, and they, the latest fabs and all this. And they spend like billions on that stuff, but they contract out to other companies. So like I think even Intel is using TSMC to build some of their chips, for example. And Intel has tons of fab capacity.
Even Analog uses TSMC.
Yeah, pretty much everyone nowadays is using TSMC. SMIC is, so TSMC is in Taiwan, SMIC is in China. There's Vanguard, which is also Taiwan and kind of partially owned by TSMC. There's like this whole subculture of
what kind of chips did you work on at Silicon
So
Valley?
the very first ones that I worked on were landline telephony, which seems like
Yeah.
Alexander Graham Bell, right? But if you have a VoIP box, you probably have, especially if you are a DSL subscriber, you probably have a Silicon Labs part in your box, and in fact, you probably have one that I worked on.
Okay.
Which
And how long
makes me
does
a
it
little
take?
happy.
How long does it take? So you work on it, and you're working on it. Because like we took classes, we actually like sat down, like draw the transistor. What level did you design stuff? Is it at
Single transistor? I kind of did
You
a bunch of stuff, but like
transistor?
put down transistors at a time, wire it up, and then like lay it out in the. So when you build an IC, you're not really like putting down single transistors. What you're doing is you're drawing regions where, so like the physical thing that you're describing is like. Where do we implant the dopants? Where does the poly get put down? The polysilicon, which is sort of deposited on top, get put down. And so a MOSFET, the way that it's built is you have a diffusion of. So I have like a base of say P-type silicon, and then if I want to build an N-channel MOSFET, then I put down a sort of a diffusion of. The way that it looks is you have these like two tubs, one for the source, one for the drain, and then there's this poly gate on top, and there's an oxide layer.
Yeah.
So, but the
middle
modern,
side.
yeah, exactly. And we say MOS, but really, in most cases the metal is really polysilicon.
Yeah.
And there's various ways that they make the poly less resistive, and there are reasons to use poly. You can change the threshold voltage of the device more easily using poly than using metal. But most modern, even not really modern, but like anything below a couple micron gate length, which is ancient technology, they call them self-aligned processes. So the idea is instead of putting down the source and the drain independently, I put down the poly first, and the poly actually absorbs dopant, it blocks dopant from underneath where the channel gets formed. So then I can just come in and diffuse the whole thing, and I get magically this MOSFET that has perfect alignment between where the drain is, where the source is, and where the gate is on top. So when you draw, like when I go from a circuit to physical layout, what I'm really doing is, I draw a region, okay, this is where the P implant goes, and this is the diffusion, and then, I draw poly here, and then we put contact.
This is where it's going to, the software will tell you this is, if you use this process, this was where your MOS will appear, and we'll sync it with your schematic.
Yeah, exactly. So you can, so eventually then what you do is, so there's a bunch of sort of checks that you do to make sure that what you've drawn is equivalent to what you've to what's in the schematic, and it almost seems magical, but like it can extract devices and make sure that, so they call it LVS, layout versus schematic, and it's almost magical. It's like I run this thing against this thing, and this thing is like graphics, and this is a schematic, and it says yes, this is all correct except you have this wire wrong. That's kind of, it's actually
it's cool. It's still
really
done by
awesome.
hand. And then how long does it take from like you poking, you poke, and then you have to get it right because it costs a lot of money to get even prototypes made. Like we have to do like $30 circuit boards. It was like, oh my God, $30 circuit boards. But like, how much does it cost to send out a prototype for a chip?
It depends. So
Let's say a basic.
What you've got for like a test wafer?
Yeah, so a lot of the fabs run what they call shuttles, where a bunch of different projects can put
they go to one
can put onto one, and you
die.
get like 25 square millimeters or something, and that's your area, and that's what you get back. Whatever you put in there, they cut it up for you, and that's what you get back. So if you do a shuttle run of like a really modern process, it's like on the order of probably a couple $100K. If you do something
What about like a 10-year-old process?
10K, something like that.
$10,000,
So like,
okay.
yeah, we just pull our money and.
Okay, so everyone puts in a little bit.
Yeah,
Don't forget to cover like the tip.
Well, I mean, honestly, like one of the biggest barriers to entry is not the technology, because really, if you're building especially analog-intensive chips, you don't need super deep submicron stuff. Like I don't need to build in like 0.22. I want to be building in like, I don't know, 0.18 is like, or 0.022, I guess, 22 nanometer. What I really want to be building in is like 0.13, 0.18. Those are really friendly to analog designers, less so to digital designers, but still an overall reasonable process to be in. And most of the investment in that case is not in the physical stuff, because it's
So
by
not like
reasonable
the
standards.
mask- not the
It's
mask
like
set.
I have to go and I have to get a piece of CAD software that does all this work for me, and like a one-seat license for that is like millions of dollars. So
Really?
like there's tons of money in CAD software, and there's like 2 companies that do it. Surprise, surprise, it's really expensive.
Yeah.
So
Well, they only have how many customers do they have? They have to make sure that they can.
It's true.
And if they make a mistake in the software, like they're probably not liable, but they probably feel real bad about it.
I've found mistakes before.
would
They feel
actually-
somewhat bad.
So I have some.
Feel a little bit bad about it.
A little bit bad.
I have still have friends at other semiconductor companies in the Northeast. I'm not going to name which one's which, but at least one of them does not actually have like a lot of their LVS process is entirely manual and isn't actually tool chain based.
Yeah. So
There's a lot of hand verification that all of your
You know what,
diffusions
though?
match.
It's not
your
a bad
schematic.
idea to also have someone go through and just check it by hand. You never know. I mean,
Yeah,
like,
there is a lot of stuff that you can do looking
it's not
by
like a
hand.
circuit boards are quite easy to verify because it's just like there's a metal layer and then maybe a couple of metal layers and vias and like it's all like binary, right?
Mm-hmm.
There's no. I mean, there's crosstalk, but like even that's like very easy to model up the this millimeter level, right? But you're talking about much smaller.
Well, even in the case that, I mean, you consider, even in the case that something is LVS correct, that doesn't necessarily mean that it's manufacturable or good. For example, like, let's say I have a circuit that draws a lot of current, and LVS is just going to make sure that I have the power supply connected, but what if I have just a teeny little wire connected to there? Well, that's not going to work, right? So there's still a ton of stuff that you have to do manually. Well, I mean, you don't have to do it manually. In principle, you could try and encode that in the way that you build the circuit, but in reality, for most things, like you want to be double checking that anyway.
It's better to get like a
Yeah, you can't sleep. You can't sleep at night otherwise. I mean,
Say it's 10 grand for an older process, but how long until you know your circuit works?
oh,
Right?
that's a good point. Like the time cost is huge. Like from the time you go, like you tape out, so from the time you like send off the mask
you're
layers.
done. You're done. You're like,
I'm done.
We
We go get a beer, and
you're drinking your beer.
and then weeks later we're still drinking beer, and the parts come back.
Okay,
so,
come back.
So it's like usually it's like even the fastest they could do is like 3/4 of a day per layer, and in reasonably modern processes, you're talking about like 20-some layers, maybe more. So you're talking about like 2-3 weeks
At least.
and
they
then
have to schedule it in too.
Yeah, exactly. So they have to start them. You have to, in some cases, like in special processes, sometimes you have to get starting wafers that are specially processed. So like in high voltage processes, where you have like SOI, silicon on insulator. That's often used for where you need like high voltage isolation between different circuits. You have to have a very special starting wafer, and those can take weeks to manufacture. And then so they go through the process, and then at the end there's packaging, which involves like
do they
sawing
package
apart
it,
the
or
wafer.
does your fab house package, or do they give it to you and you get a bonder and you do it yourself?
Depends. The fab houses can package, but often they don't have a very wide range of package. Especially somewhere like TSMC, they don't care about older packaging, so they build stuff. Like most of their really high money stuff is in like chip scale packages, where it's like ball.
They'll give you like a BGA.
Solder balls or something.
Yeah,
exactly.
but that's it.
So for the most part, especially for engineering, engineering boards, you don't want that, right? So you send it off to different fab houses like Amcor or ASE, or there are tons of these places. There are some places in the U.S. as well, although those are usually used for lower volume. You could imagine it's much more expensive to do packaging here. But that process, just getting it to the packaging guy, they saw it apart, they package the thing, they send it. It hits customs, another week and a half. So you're talking about like usually 5-6 weeks between tape out. Yeah, and writing documentation while drinking.
So then you get it back, and then let's say like, thank God, you got it right.
Okay.
So then you have to go through the test procedure. So like you have hopefully some people you help direct the test procedure. How long does it actually take until like I can get samples from Silicon Labs?
It depends. If it's a chip that's targeted at like a few like really super high volume customers, basically if the customer is important enough, we'll say, we're gonna just barely check that it works and then we'll give you samples like immediately. And usually what happens is like by that time we don't have any automated test up and running. So
usually they say it doesn't smoke, it runs our first test and then we give it to you. You see if it works in your application. Works on your application, great. If it doesn't, then we have to go back to the drawing board anyway.
Exactly. And so usually in a case like that, that's like you get it back. Maybe we have 2 to 4 weeks. You know, sometimes for whatever reason we have even less time than that. But let's say we have like a 2 to 4 week span where we get to look at it, test all the circuits, make sure things look reasonable, and then we hand off, you know, maybe a dozen parts to somebody to sample. But if you're talking about like getting it into the channels where somebody could actually order it, the earliest you would generally expect is 6 months, and that would be pushing it pretty hard. And again, it depends on the part.
I see like part announcements, and I'm like, okay, 9 months.
That's what I assume. Absolutely.
From a part announcement to like, I can actually get someone at the company to send me an engineering
So
sample.
there's a few reasons for that. Like there are quality processes that go on behind the scenes where like we get our first lot of parts back, and maybe that's like 4 wafers of engineering stuff. And you can imagine that there's random variation in all these parameters in the manufacturing process. And so what the fab does is they give you a guide as to like, here's typical, this is what all the parameters look like typically. Let's say the threshold voltage of the N-channel MOSFET is 600 millivolts typically. But maybe they have like fast and slow corners where like maybe the fast corner the threshold voltage is only 500 millivolts, and at the slow corner it's like 700 millivolts. And then on top of that you could have temperature variation causes changes and stuff like this. So generally what you want to do is you want to see how the part looks across manufacturing corners. So then maybe I'll get wafers that are all fast or all slow, or maybe I'll say, well, I want the P channels to be fast but the N channels to be slow, right? So you can imagine that there are tons of these combinations.
Have you ever worked on a chip? I mean, either it's you heard of someone who works on a chip, and it turns out that it was not manufacturable.
Yeah, absolutely. There was
an idea, and you're like, oh, we could totally make this, but then you're just like, after many tries, you're like, we just can't get the yield, we can't get the manufacturing.
So there are a couple times something approximately like that has happened. In one case, we had a part where, in principle, everything was fine, and at typical, things were pretty much okay. But the fab had much wider variation in their corners than they told us they did, and so the result was that we would have some production lots where there was maybe 10% yield, and then other production lots where there was like 90% yield.
We had something like that at Analog because the parts that I was an apps engineer for were all these ultra high speed parts where any variation in sheet resistance would have everything fall off. Like if you can't
spec tell them like you must spec this wafer before you use it.
Well, no. So what happens is it's a stack up aggregation in the entire process, from how they handle the wafer and what the base wafer looks like to all the different dopants and everything else. Just through you have an error stack up for the entire process, and if you have 20 or 30 processing steps, there's a lot of different variability that can come in, and also you have.
Is this why you'd want to maybe own a fab if you want like a high-end company?
It's why having a fab is like a blessing and a curse, because one of the guys I work with now used to work in semiconductor equipment, like actually making implanters, so the equipment that fires the different dopants into the silicon, and small variability in like the power supplies of how those work can change how much dopant gets added. So
it's a very small amount of dopant.
Yeah, and so like the error comes in everywhere. But what happened is we spec'd a distribution on how much resistance was okay for these high-speed parts, and we set our test specs based on what we saw from a couple of lots, and it turns out the lots were too close. The fab shifted, and we went from 95% yield on our parts to 15% yield on our parts.
Yeah,
and then we're like, do we take the cost hit, or do we update the data sheet and talk to the customer?
Or we just charge a lot.
You can imagine,
or do we just start charging more money, but then the customers will be like, what?
Yeah.
So it's
it's
definitely
do you have any more questions?
I don't know. Fabs are terrifying.
I'm going to open it up for questions for both of you. Thank you for that. Everyone really liked the chip fab stuff. That was incredible.
That was intense.
Yeah.
I don't know a lot about chip fabs.
All right.
What's the favorite?
It's actually really
Can you
fun.
actually talk about any of the other favorite chips that you worked on at Silicon Labs, or while we're waiting for
Sure.
Just
let's
like,
see.
just
So
name a couple of them.
I worked on some telephony stuff that, I mean, no one here is going to be really buying
Okay.
because no one buys it. Like 3 people buy them. Most recently, I worked on digital isolators where you have like you have inputs and outputs that can be like thousands of volts apart. So if you have like safety isolation stuff, or if you want to talk to like something that's on the AC line or something like that, and you want to remain safe, like you can isolate Ethernet or USB or something like that. Those are kind of cool. And like I've done some projects just at home where I needed an isolator, and the ones that we build are much faster than like optos, and they.
So can you actually do like Ethernet, gigabit Ethernet isolation?
Like 100 base T.
100 base T.
Gigabit is, we looked at one, and it turns out that the market isn't really that big for something that fast.
No,
But like
like
100
the
base T
range,
is
but
like
100 base T.
100 base T is like no
that's
problem.
cool.
If you do it right, you actually want that sort of isolation on anything in medical because you have to
Yeah.
have double isolation
Yeah.
on all patient contacting applications.
Yeah, sure.
That's why people will go so often for battery powered because it's way easier than having to deal
I
with
know, seriously,
isolated communications.
Plugging it in. If you've got enough, a couple double A's, you put like fuses and resistors in,
Yep.
like it's easy.
Batteries are also nearly noiseless, which is really nice. Like
I know.
power supplies are beautiful.
I know. It's
All
beautiful.
right.
Can
here's
you
a-
isolate the charging circuit? Maybe? Okay.
Yeah, actually, that's the most recent one that we designed was that. It's an isolated power converter. So it starts itself up, and then like you've got thousands of volts of isolation from the side that's sending the power to the other side. And so you could like charge batteries over like a very big isolation barrier or something like that.
All right, we're going to extend the show for 10 minutes, something we normally don't do, to answer some questions. So start asking your engineering questions. We'll get to them as fast
Especially
as possible.
questions about IC fab
Yeah.
and designing circuits with rectangles.
Okay, this first one's for you, Lady Ada. Can I use pins 11, 12, and 13 on the Arduino with the data logger shield to turn on LEDs?
I would not. They're
Okay.
used for the SD card.
Someone wants to know, is there plans for a Raspberry Pi Pibo case that'll work with our Pi TFT? Yeah, they're working on it.
I think Pi Moroni is working on it right now.
Yeah.
So go ask them.
Next up, any plans for an Adafruit retail store in NYC? It's really expensive to do a retail store. However, Radio Shack has our stuff.
Yeah, Radio Shack has it.
Also, the NYU bookstore
NYU
does.
bookstore.
And we're also looking into all sorts of other things. But we would only do it if it made business sense.
Also, that other store, the one in Union Square-ish area. What's it
Which
called?
one is that?
The geek toy store.
The Geek Toy Store. AC Gears.
AC Gears.
Okay.
Yeah.
They have some stuff.
Got some stuff.
All right. Riyadh, what's that crowbar on your shirt? What is that?
I think it's a video game thing. I think it's Half-Life.
All right. Excellent.
Come on, Half-Life is awesome, right?
All right. I want to know. All right. Next up, how can I supply constant voltage to a DC motor with a voltage regulator that outputs enough current? Question mark.
Yeah, you can. If your DC motor has a current limit, and that current limit is under like whatever the voltage is that you're using. So just make sure you stay under that current limit, and you're probably usually the motor says on the side like 3 to 6 volt, and if you go over it, it'll just eventually die. But if you go under it, it might not start up. So just go somewhere in that range.
Okay. Next up, how long until chip fabs are accessible to high-level hobbyists, electronics experts?
Good question. I mean, I would say that because of the expense of the CAD tools, like that's the major barrier. Like if you wanted to kickstart a chip, it wouldn't really, like it's totally within the realm of stuff that people have done on Kickstarter before. Like you see 10K-ish or 50K-ish
Yeah.
Kickstarters, and that would be enough to get, if it's a small chip, that would be enough to get thousands of
But
chips.
for digital logic, it might make more sense just using FPGA.
Oh, absolutely,
It's
because-
only when you want to do some sort of weird analog or high voltage thing.
Yeah,
right?
no, absolutely,
Weird.
absolutely. For if you're doing digital stuff, FPGAs are awesome. Like the FPGAs that you can get now, cheap, are just like mind blowing in terms of how much capability they have, and like they're in really advanced processes, and the tools are good and free, which is important.
Yeah, but like the Parallax blog talks about how they're designing their own microprocessor in-house. They designed it on FPGA and they actually sent out engineering samples as like, it's an FPGA, but they're actually getting the chip fab. Then it's kind of an interesting tale because this is like really, really hard and very expensive. I don't think they're using any intense processes, but it's just, yeah, I think there was
It's a lot of work.
maybe-
Like it just
and if you make a mistake, it's like you got to start over.
yeah, it's tough. The work that that software in the FPGA does for you is actually, I mean, like that thing is doing a ton, right? Because you're going from something like Verilog or VHDL to gates, right? And so there's this process of translating it into gates and then understanding the timing relationships between the different signals, and so all of that has to be done for IC design as well. Except in that case, like the constraints are slightly different. Like in the case of an FPGA, you have these sort of this fabric of lookup tables, and you're programming that fabric. In the case of something like an IC, you just have a library of gates, and you just put stuff down.
So synthesis and time enclosure is actually what I used to do at IBM.
Oh.
So when I was working at ASICS, one so like the FPGA runs synthesis in order to sort of do all the gate level connections, and you might have your adder over here, and then you have like communications bus over there. And when you're doing an ASIC or an application-specific IC, it's pretty much the exact same thing, but you have routing and timing synthesis tools that will actually look at all of the different I/O and all the different data paths, and you figure out what the timing skew is, and you simulate that. So that's also hugely involved tool chain, and there's a lot of what the apps engineers at IBM were doing, and I was helping run simulations. But you'd run a simulation, and then you'd say, okay, well, the timing path is really circuitous, but we're limited by the amount of gates we can put on this part of the chip because we have density issues, or we can only put so much capacitance here. We have power. I did power supply simulation, so we have power supply issues, and an apps engineer would have to go in and try to actually manually correct it. So even the digital synthesis is not straightforward.
Yeah, I did a bunch of that this year actually, and we were doing some. We were pushing we were in quarter micron, which is old. Like, but we were going at like 500 megahertz or so. So like for quarter micron, that's pretty respectable. And like the amount of work that the software does for you is at this point just mind blowing.
And
like,
FPGAs now are like so beefy, and you actually have like power and speed,
awesome.
and like all of those things which you wouldn't have before someone actually made those standard product
there's
lines.
some people who want to do. I mean, like we talked about Square designed their own chip for the card reader because it's like this weird inductive, circuit, and like they didn't want to have a big coil, so they did more processing on the digital side by designing their own chip. I mean,
you can kind of go halfway. There are some companies
low power enough that they could run off of like the audio jack, right? It could.
That makes sense.
They wanted to leak enough current from the audio jack so that they didn't have to. They used to have a battery. And even the battery lasts like 2 years, they wanted to get rid of it. So
it's expensive.
But they had to they probably contracted out, and it was probably a big investment. And so they're like, okay, we have to make at least 1 million of these. If you're not making 1 million chips, it's really hard to justify.
It's true. It's true. There are companies that kind of meet you halfway, where they will do a lot of the work of going from like VHDL or Verilog to the chip. So like some of the companies that make the software will also do sort of semi-custom like ASIC stuff. So like Cadence is a company that they have like this huge software suite. They do everything from like board layout to IC design. And like everything in between.
I also know, like I remember, like in Color Kinetics, they did a chip that was based off of a microchip PIC, and they actually went to Microchip and said, "Look, we really like this chip, but we want it with like 4 more timers."
Yep.
And Microchip was like, "Well, how many are you gonna buy?" And like, they said, "Well, we'll buy like 500,000." And they're like, "Okay, we'll design a chip that's just the same thing with 4 more timers for you," because that was easy for them.
Absolutely.
Don't people also pass core modules around? Like I thought for a while for different processor modules, memory types, there was a move to actually exchange those IP
basically
blocks.
modules. It's super optimized. Like even like timer modules like this PIC chip. It probably didn't take them more than a couple of weeks. Just like copy and paste the timer and just crossbar it to whatever IOs. Do we have
there's a lot more questions.
Okay.
Does it make sense to prototype in FPGAs before you do IC work?
Absolutely.
Yes.
I've done that before, for sure. For sure.
If only to get your I/O flow correctly. Like one of the things we would always mess up. Not we always, but one of the things you mess up.
All these we were totally
things you can mess up.
All the things you can mess up are things like signal routing. So if you have a connector on your board and you need it to go straight into your IC, and maybe it's a high-speed connector, so you don't want to flip it over and have vias.
What's up with that? How come it's like all these HDMI and DisplayPort connections? They flip the.
That's because
connector.
the designer doesn't think about when you get that problem with an HDMI chip. It's because the designer didn't actually think about the signal flow. They didn't put their chip.
Come on, they didn't even they build it once.
No,
Maybe they built
didn't.
the connector on the other side.
No, that was my job as an applications engineer. And so one of the arguments we would always have is the designer would say, "Oh, just put the connector on the other side, and the signal routing will be fine." And then the TV manufacturer will be like, "Up yours! I'm going to put all of my components on the same side of the board."
Because
why would I have it
single-sided, right?
They always, so the designer doesn't think like, "Oh, it would be really expensive if the customer made this board double-sided." So they just go, "Well, like rotate it; it'll be fine."
If you look on the Retina board, we do that, and so there's this weird like
you always have to do this crossover
because you have to cross over
and then you have to
match them. So there's always this like weird like bloop bloop.
Oh,
you
should
some
of the chips I wrote data sheets for, it was even worse because like we had to do trace matching, but the half of the diff pair would be on one side of the chip and the other half would be on the other side of the chip, and that was a giant pain in the ass. Unless you rotated the chip diagonally, which is also a real bitch to manufacture.
Oh, but I've seen a lot of boards like that where the chip is instead of like this is
like
that. Would you go in and can you smack them? Are you able to like smack them?
So the other
you got smacked?
Yeah, actually, one of the people on my team had a little baseball bat, and she would come around.
Really? What did you do to deserve that?
Usually, I broke the Sims.
Okay,
he broke the
simulation.
simulation.
Like building
but
the build.
The other thing that happens is people want to make drop-in replacement parts, so it's just like the Arduino header.
Yeah.
One design, and everyone else has to do it that same way.
Like something, and then Silicon Labs like, well, man, improve it, but we have to have it like.
And it has to be a drop-in replacement,
because
and
then
so
you
get a lot of
automatically.
inheritance
On
and
the
flaws
other
like
hand,
that.
what's nice about that is how every op-amp has the exact same pinout.
Yes,
sure.
Quite nice.
Sure.
All right, any other questions?
All right. Well, I mean, this is just a general one.
Good question.
Yeah. If you wanted to get started with FPGAs, do you guys have a suggestion, like a board that you like, or
I usually just use a Spartan 3.
We have a really good
deal.
deal.
Y'all have one that's really good.
The Dio Nano is a really good deal. It's $100. It comes with RAM, a nice little case. Software comes with it. USB connector for downloading.
Yeah, of course. Those things are awesome.
It has an accelerometer. It has all the connectors. It's actually because we have a lot of people who are like. We also have the Mojo, which is has more tutorials that are a little bit like more maker friendly. So those are the two FPGAs that we carry. Like I haven't done FPGAs since like 6004.
Oh, they're so awesome.
I'm done.
It's like you just feel the power and
I know.
raw silicon in your hands.
I did some CPLDs once, and I was like, this is kind of cool because it is interesting. Everything happens at once. But those are the two that I looked at the specs, and I was like, even though I didn't do more than just like blink an LED on them, I'm like, these are pretty good. $100 is a good deal for an FPGA nowadays.
Yeah, it really is.
And because we have lots of beginners, last question of the night before we do the trivia question: what is an FPGA?
What is an FPGA?
An FPGA is a field programmable gate array. So it is basically if you had
if you stole my iPad,
a chip that was full of potential gates, and I'm not actually sure how it connects the gates with the field programming.
Like it's this repeated fabric of lookup tables. So if you look in like data sheets, you always see LUTs. It has 600,000 of them. Lookup table. So the idea is it's like a 6 input, 6 output lookup table, which is to say like you can make any logic function you want, right? Because there's like this equivalence.
It basically
between
has like
Boolean
millions of NAND gates.
Yeah, exactly.
Millions and
then
millions.
You can just connect them arbitrarily.
The software will burn connections between them in any arrangement you want, and so. It's basically anything you want to do is instantaneously fast, but everything happens at once, which is opposite from microcontrollers where things happen one at a time.
Well, you can always, I mean, so then it's a
You can
different style of,
emulate-
it's a
you can
different
emulate a
style of design. So like the
semiconductor
idea is
as a
usually if you're
microcontroller.
building something in an FPGA, then you design a state machine, and then like your state machine is stepping through states, and sort of that's how you, so like both Verilog and VHDL, which is presumably what you'd use to describe this, have these notions of like these clocked circuits. And so I have this system that transitions from state A to state B to state C to state D.
One's holding some
etc.
avocados or something. So you have these avocados.
So
They
no,
are
it's
delicious.
so an FPGA is very analogous to having if you had a breadboard just full of TTL logic, right? NAND, NOR, XOR, some memory.
It's
and
very big.
It's very big.
It's like
and
a football field size.
And
Don't
what we
forget,
actually
don't forget flip-flops.
and flip-flops and
And
latches.
flip-flops.
And so if you were to build an old style TTL, which is transistor logic, circuit and actually be able to clock things through and have defined states, that's what an FPGA is analogous to, as opposed to a microcontroller, which is actually a processor architecture. But if you wanted, you could instantiate a processor architecture on an FPGA. And
If it was big enough.
If it was big enough and it had enough memory.
Okay,
You'd be
great.
surprised that most
And people do
FPGAs
that.
these days are totally big enough to
Like
put
a
down an
Vertex?
8051 or
A
something.
Vertex, no problem.
All
So we
right,
should,
and that's the show. It
do
is.
the show.
Yeah. Thank you so much, guys. That was fantastic.
Okay.
Surprise visitors are good visitors.
We learned a lot of fabs.
Yeah.
See, we know all sorts of stuff
This is
here.
good. All right, so we're gonna do a trivia question.
Okay.
Lady, what are the rules? Fast.
Rules are if you want anything on the trivia question, you don't get to enter again. We only have one winner per lifetime. This week, the winner gets a TFT shield for an Arduino version 2.
Okay.
They're sold out because people bought them all, but we have one right here, and you get to have this one. And I kept the little plastic cover on.
Here's
so
the here's the question. Whoever posts where Riyadh just used to work, which was the topic of the conversation most of the night,
Yeah, put the URL.
URL or the name of the company in the chat. And,
Good thing I'm not wearing the T-shirt.
yeah.
Yesterday I was. Would have been weird.
You're not there anymore. Now.
It's not. It's
That's
not.
true.
It's not.
Now you're in school, right?
now you're a trivia question.
I work at NYU actually.
You're
okay,
working at
Fiona Hess won. You won. Congratulations, Fiona.
Silicon Labs.
Silicon Labs. SILabs.com.
Someone was paying attention.
Fiona,
I called them Scilabs, but I
Email
Yeah, so we
support at
call ourselves
adafruit.com
Scilabs.
and you,
Okay.
Fiona, email support at adafruit.com and you will get
A TFT shield.
a TFT shield. Okay, everybody, that is the show for this evening. Bring the other mic. That is the show for this evening. I have to
Hello.
talk into a microphone. Thank you, everyone. Thank you, all our staff members that were here for the evening, helping out in the chat. Thank you, Riyadh. Thank you, Waz, for
Thanks
stopping
for
in.
having us on.
Thank you,
Telling
everyone.
us everybody at FPGAs.
Yeah, thank you.
Avocados.
Thank you, everyone,
Squeeze them.
in the show and
I have
tell.
knowledge to tell you.
This
And-
is knowledge. This is what knowledge looks like.
Well, Waz is
The
going to be
fruit
back. She was trapped in a snowstorm, and she texted us today, and this all worked out. It was very good timing. So this was wonderful. And we got a chance to show you Adafruit.
Not only was it good timing,
Yeah.
but we
It's a cool
talked
place.
all about timing.
Yeah.
Time
the-
to
It was
put some
the
closure.
last time I saw Riyadh, we were at Maker Faire Austin, and Adafruit was in a condemned building, and it was about the size of the corner over here. It was really tiny, and we had, I think,
Oh yeah, that's when
we
we were
had-
in the building that was condemned.
yeah, and we had like
Good
we had
times.
2 people who worked with us, and now we
Yeah.
have 63. So,
And now we have a big picking place.
so the next time you visit, we'll see how things are next.
So what lab are you working at NYU?
Courant, the math and CS department.
Okay.
All right. Okay, everyone. Well, thank you
Fast
so
tips
much.
NYU.
Lady Ada, if you can, oh, not yet. Wait, I got to do the thing.
There's more Shake Shack here.
Yeah, don't forget the code is Mo, 14% off. It expires in about an hour and a half. No,
Okay.
sorry, 45 minutes.
45 minutes.
Here is your moment of Zener. Wait, I gotta show the picture of a cat first.
Okay,
All right,
cat,
there's
hi.
Mass.
yeah.
All right, here's your moment of Zener.
Nice.
And if you can flip the switch on the music.
Okay. It's the DJ Little Bits.